Okay, welcome and thank you for joining us to this exciting panel discussion entitled Soil Matters, a dive into geosciences with industry experts. This event is a joint initiative between the University of Alberta Geotechnical Centre and the UA CGS Student Chapter, which we will introduce shortly. Before we start, we would like to acknowledge that we are currently living and working on Treaty 6 territory, which is the traditional land of both First Nations and Métis peoples. We acknowledge that the Indigenous peoples were the stewards of the land before us, and we thank them for their efforts in caring for the land and water we use today. We would also like to acknowledge that this event is an inclusive space where we are here to listen, learn, share, and discuss in a respectful manner. We are not here to debate or discredit any experiences shared by either panelists or attendees, and we will not tolerate any inappropriate language or behavior. We are all here to learn from each other so that we can make our industry a more welcoming place. So please be respectful of others people's thoughts and experiences. That being said, we have a great program lined up for everyone today. The program includes a brief introduction about the UA CGS Student Chapter. Then we will jump into a panel discussion with our wonderful guests, Drs. Gord McKenna, Ahlam Abdulnabi, Nelsha Slingerland, Deji Dunmola, and Silawat Jeeravipoolvarn. The plan for the panel discussion is that we will begin by asking 3 questions to the panel members to break the ice, and then we will open the floor for any questions that the audience members may have. Please don't feel shy about either unmuting yourself and asking a question at this point or simply typing your question into the chat box. So at this point, I'm just going to give a brief intro about the UA CGS chapter. I will share my screen. Can someone confirm that you guys are seeing the presentation?
Yes, it looks good.
Yes.
Okay, perfect. All right, so firstly, I just want to thank everyone for being here with us tonight. Our whole team is very excited about this event and the wonderful panelists that we have here today. So our group that was established in 2019 has a bit of a mouthful for a name, but it's the University of Alberta Canadian Geotechnical Society Student Chapter. We're a student-led group at the U of A that is backed by the CGS. In 2019, the CGS launched a nationwide campaign to have student groups propose concepts for student-run chapters to help further inform people of the opportunities that a career in geoscience can offer them. The initiative by the CGS has led to 8 chapters being formed across Canada, one at UBC, ours here at the U of A, one at University of Saskatoon, University of Manitoba, Queen's University, Dalhousie, University of Western Ontario, and Waterloo. So our main goal as a student chapter is to help educate undergraduate students about geotechnical engineering and geosciences. We do this through a number of methods, including events like this one tonight, a monthly newsletter, and promotion of available geoscience events throughout Alberta and Canada. One thing we highlighted in our original submission to the CGS was that there is a clear underrepresentation of geoscience in undergraduate degrees. Oftentimes, students only become aware of the profession in their 3rd year, and often only if they are within the civil engineering branch. Through our work, we hope to improve the awareness and understanding of what the geoscience industry has to offer and to bridge the gap that it currently exists between engineering students and the industry. So as I mentioned, one of our main techniques of accomplishing this is through events. We've held a number of events up to date. This includes an informal student mixer, a weekly mental health meeting space, a presentation by industry representatives to teach students about geoenvironmental and geotechnical engineering, a women in geosciences panel, and we have a virtual event coming out soon that consists of Pecha Kucha style presentations that we will be uploading to YouTube and our website. So please check that out once it's ready. In regular times, we would also be looking to get more hands-on style events planned. We had one planned that was a CPT and drilling investigation with ConeTech and mobile augers here in Edmonton. Unfortunately, due to COVID, we were unable to run that event, but we hope to get back to that soon. We've also like to co-host the annual retaining wall competition that's held here at the U of A. Jointly with the CGS chapter. So maybe once the return to school happens next year that they just announced, we'll be able to get back to the in-person style events. Another initiative that we've been working on this year is our monthly newsletters, where we highlight interesting topics with the geoscience field, conduct interviews with members of the U of A community, and try to provide general information about the profession. We've put out about 7 newsletters thus far, with topics ranging from a discussion on women in STEM, to a review of the Grusin Hill landslide in Edmonton, to an interview with one of our master's students at the U of A, Kwaku Amoka. Fernando will throw a link in the chat box in case anyone's interested to dive further into this. All of our promotions and information can be found on our website, including one of the items that I think is particularly useful for students and even young industry professionals, which is a very detailed list of companies in Alberta that hire geoscience professionals. This list includes links to all of the company websites where individuals can research companies and even apply for jobs online. So it's a really great tool to start exploring what's out there. I'd also be remiss if I didn't quickly thank our supporters, the CGS, who is the National Geotechnical Organization in Canada, the local chapter of the CGS, the Geotechnical Society of Edmonton, who have been very supportive since day one, and of course the U of A Geotechnical Center, who have helped plan and promote events with us, including this one. So just as a last word here, we'll be having our annual AGM this summer, and we would love to have new students, undergraduate or graduate, join our executive board. If you or someone you know might be interested, you can shoot us a message through our Contact Us page on our website. Now let's get back to the panel event. So our panel today is composed of a cross-section of the geoscience field, from intermediate to experienced members, with a bit of a specialty lean towards tailings and landform specialists. Our first panelist is Dr. Silawat Jeeravipoolvarn, who is currently working as a geotechnical engineer at Thurber Engineering in Calgary, Canada. Silawat completed his master's and PhD here at the U of A with a focus on slurry characterization and dewatering behavior. His work includes a wide variety of projects from software development to residential and commercial building development to mining geotechnique, and he even worked on an amusement park. We're happy that Silawat is here to share his over 10 years of geotechnical experience with all of us. Our second panelist is Dr. Nelsha Slingerland, who is a mine closure specialist currently working for Golder Associates in Vancouver. Nelsha designs mine waste landforms for closure, develops site-wide mine closure strategies, and occasionally has the opportunity to write national mine closure guidelines for developing countries that through time become regulation. Nelsha took a very interesting path towards obtaining a PhD in geoenvironmental engineering here at the U of A, coming from a background in landscape architecture. She can provide an interesting insight to anyone considering non-traditional career paths and has done amazing research on geomorphic landform design and particularly interesting work on the scour effects caused by forces like wind over time. Our third panelist is Dr. Deji Dunmola, who holds a PhD from Carleton University in Ottawa in geoenvironmental engineering with a specialization in mine waste geotechnique. Deji is currently a geotechnical associate with the mine closure research team at Syncrude Canada. He's an expert in measuring, characterizing, and predicting the geotechnical trajectory of mine tailings deposits from deposition through stabilization, capping, and eventually becoming ready for reclamation. He has over 15 years of experience in the oil sands and base metal mining sector and has published over 30 technical and subject matter reports. Dr. Dunmola brings a very interesting perspective to our panel through his hands-on research at Syncrude. Our fourth panelist is Dr. Ahlam Abdulnabi. Ahlam is a research associate of geoenvironmental engineering at the U of A. Ahlam was originally trained as a geotechnical engineer where she worked on projects involving site investigations, foundation design, and shoring, but her graduate journey at the U of A brought her in a slightly different path. Ahlam completed both her master's and doctorate degrees at the U of A, focusing mainly on mine waste management. Her areas of expertise include geotechnical and geoenvironmental characterization of mine waste rocks and tailings, deposition and consolidation modeling of oil sands and hard rock tailings, and design of soil cover systems and assessment of long-term integrity. Ahlam has done some incredible work on soil cover systems and is one of the smartest, kindest, and most helpful individuals that I've come across in my engineering journey, and we're very lucky to have her with us tonight. Our final panelist, Dr. Gord McKenna, is a geotechnical engineer and geologist with over 30 years of experience both in mine operations and as an international consultant for oil sands, coal, diamond, and metal mines. Gord founded his company, McKenna Geotechnical, in 2017, which has allowed him to broaden his audience and share his passion as a landform designer and builder. He is also an adjunct professor in the Civil and Environmental Department here at the U of A and one of the founding chairs of the Landform Design Institute. His specialties include mining geotechnique, tailings dams, soft tailings, and landform design. His teams have designed and built over 23 watersheds that cover 44 square kilometers and host over 37 wetlands and 101 kilometers of streams. His accomplishments as an engineer in person are many, and we are glad to have him here to share his perspective. So with everyone introduced, let's just jump right into the questions so you can stop hearing me talk. So I'll direct the first question to Nelsha and Gord. What are some of the largest challenges for geotechnical or geoenvironmental engineers today? And how do you see younger industry members rising to the challenge to solve them? We can start with Nelsha.
Yeah, I guess the first thing that comes to mind is really the take-home message from Tailings and Mine Waste last year, a conference that was held, I believe, in Colorado. And the message there was specifically related to tailings and the need for so many more tailings professionals as we move forward with development of this area of study, really. So this is a hugely complex area, very high stakes area to be working in, particularly with respect to geotechnical engineering, and a huge demand for professionals with a passion for this and good ability to do that kind of work. So I think there's a lot of area to grow there. I always encourage people to take a look at that area of study. There's a lot of job security, first of all, in that, and certainly a number of jobs available in that area. Gord?
Yeah, I'd echo exactly what you said there, Nelsha. The tailings, especially the resource industry and extraction industry, and society looking for more than what the mining industry has been providing and the major extractive industries been providing over the decades. Less risk, greater returns, more sustainable development. I think we're coming in this group here on the line is graduating at a really good time. That we've got things pretty good. These major disciplines are well defined. There's good foundations for all of them. You're getting excellent training at the University of Alberta in so many of these areas as a world-leading university in this regard. There's lots of textbooks on these things. So there's some really wonderful modeling, and something that Nelsha showed in her PhD research is that some of these complex models that used to be really unavailable, or we didn't even have PCs when I got out of school. But now you can kind of nip home and run a flak analysis overnight for deformations and liquefaction, or you can, with a little more effort, you can run some erosional modeling, different things. So there's a bunch of opportunities. And I think the challenge that goes with that for people is we want you to be really top-notch specialists in an area, but we also need you to have a very broad understanding of the field, and hopefully an international understanding of your geotechnical and geoenvironmental work. Lots of field work, lots of office work, lots of study, lots of education. It's hard to fit it all in these days. And so I think that's the challenge, is stewarding your career to both pick up your trade and also some specialties along the way.
That's great. And I tried not to date you too bad in your introduction there, Gord, but I think you did it yourself with that computer comment.
Yeah, I remember we got our first IBM PC Junior and the 12 of us fought over it.
Yeah.
and the little yellow screen. Yeah.
Yeah, that's great. Yeah, it's always nice to hear that a lot of the work being done at the U of A is very positive, and it's going to be, industry driving in the next years to come. So it's good for all the students at the U of A and anyone in the industry that's looking to get involved in any tailings work. So we'll move on to the next question then. We'll direct this one towards Ahlam and Deji. So what advice would you give to young professionals who are looking to develop their career in geotechnical engineering? We can start with Deji.
Thanks for the invitation. It's definitely a pleasure to join the good company. I would say that you guys at the U of A are very fortunate that you not only have really top-notch program in the geosciences, but you've also got faculty that are well dialed in, right, into what's actually happening, the leading edge of practice in the industry. So in my mind, you've got the basics in terms of the education that you need to succeed. What I think will be helpful, which I've found in my experience, is sort of your posture in terms of, I would say, being really curious and inquisitive is a really good posture that I think will be very, very helpful in your professional career. Asking questions of people that are experienced in the industry that you get to work with. But I will also say just be open-minded. Be open-minded in terms of taking on new challenges. I joke, it's not a lot of joke, but I joke that before I joined the oil sands about 10 years ago, I've only worked with base metal tailings that had plasticity index of about 2 or 3%. So the first time I got to know that oil sands tailings have plasticity index in indices as high as 35%, it was strange to me, right? But I was really, really open-minded to really learn what this strange material is all about. And the last thing I would say is really, really try and own your problem solving skills. You will find out that in real world, nobody really cares about, your title, your PhD or whatever you're coming with. What people care about is, are you able to solve their problems? So make sure you focus on your problem solving skills. Thank you.
Great. So thank you, Deji, for that. And first of all, I'd like to thank Kevin for his kind words, as well as the CGS Student Chapter at the U of A for the invite, and for everybody here on the call today for taking the time out of their evening to listen to us. I agree with a lot of what Deji mentioned, and what I would like to add to that is think about your career in the geosciences as a well-rounded type of deal, right? So as Deji mentioned, you will get a very strong technical background here at the U of A, but your job as students is to work on the other aspects. So you would want to strengthen your leadership skills, your social savvy skills. And I know most of us are like that types of people who are geared toward technical things, but it's important to have these people skills as well, because there's a huge part of the job is supervising people and leading people. The other thing that I think is a very big aspect in our line of work is communication, both written and verbal. So take the time, and I think it was Dr. Wilson in one of his classes who said, well, if you don't like writing, then you're in the wrong profession, because we do a lot of writing. But that's the bad news. But the good news is this is something that you can learn and develop and grow and flourish in. Pay very special attention to the network that you have around you. Make a very conscious effort to cultivate and grow a strong and healthy network. These folks are not only going to help you grow your career, but also they might be your potential bosses one of these days. So be careful how you interact with your classmates and people like that. And my final comment is about statistics. You would be surprised how much you're going to be using statistics in the real world design, and being able to really understand what it means if I have a variable that really, and that goes back to the technical a little bit, but always have that sort of skepticism at the back of your mind when you're doing these kinds of things. Again, I'll echo what Deji said, keep an open mind and don't limit yourself. Don't I like what Kevin said about Nelsha's sort of journey into her career. it's good to have a plan, but it's also very good to be flexible and be able to, adapt in this world.
Yeah, that's great. I think definitely open-mindedness has been helpful in my career, and I'm sure most people's careers that have been in here. I've done things like water sampling, drilling boreholes, monitoring piles, things like that. And then you learn a little bit about the industry each time you do something new. So I think open-mindedness is definitely a big thing. And well, I guess writing is also a big thing, which a lot of people coming out of undergrad aren't too happy about when they find out that you're going to be writing reports on the daily. But you learn to get better at it for sure. So the next question before we open the floor up to anyone in the public who wants to ask a question today will be towards Silawat, and we'll do Gord again. So in your experience, what does the general workflow of a geoscience project look like?
So in general, like the geoscience is quite similar to typical civil engineering projects in a way that in general, we go with the planning, data collection, including basically field and lab work, analysis and designs. And once we good with the design, we got like, constructions, we go to construction, supervision, and typically end up with the some of the service and maintenance. But for the geoscience, we also do have a strong emphasis on some of the material understanding. What do we have beneath our ground here? Like how are we going to put things? So like, a lot to do with understanding of the material and understanding the geology. So so that's something like that. But the workflow also interesting in a way that like, the open minded many of the experts actually mentioning is that like sometimes we may have to go back to the planning from the stage to revise some of the initial concept to come up with a better solution as well. So it's quite dynamic and interesting like a subject to work on. Thank you.
And why don't I build on that? And since many of us here are involved in the at the graduate level and research and development, is that the many of those programs also follow as Song talked about, the sort of the civil engineering workflow area. But in R&D, there's a really common occurrence that you can watch for, and almost like an internal spectator, is you'll have some kind of bright idea for some new way of doing something, or new kind of tailings, or in the little story I'll tell here is about landform grading and about going in with dozers and changing the shape of a waste rock dump or a tailings pond to better handle the drainage and perhaps look more natural. And you come in with this, you might have a consultant involved or some university people involved, and most of the people around you will kind of have a bit of disbelief and wondering what you're doing and why you're mucking around, why aren't you putting ore in the bucket and getting it down the pipeline and all that kind of stuff. And but you'll find one or two people who are kind of supportive and kind of interested in it, often the younger people. But you're kind of fighting an uphill battle, and then as you go and do some additional work, often in the field, and you get more people seeing it, and they kind of go, oh, that looks kind of interesting, and in this one case, we landform graded part of a hill slope at Syncrude, and the Syncrude president came out and had a look and said, hey, you guys have been mucking around for a while, this looks pretty good, and he went back to his office, and within hours, we had 4 shift supervisors phoning us saying, we want you to come talk to our team meetings and teach us how to do landform grading. And we've got a project and we need blueprints by Monday. And so if you watch for this, you'll see that, well, many of these brilliant ideas amount to nothing and don't work and die on the board or in the lab. And that's good that we've got a whole bunch of things we're trying, only some of them are going to make it all the way. But the ones that do, and you can watch for this, your colleagues and the people you're working for they'll jump past what you can deliver pretty quickly. And for all the times you get disappointment, it's those days that you kind of live for. You still have to explain that you're not going to get blueprints on Monday. That's going to take a couple months or whatever. But it's pretty exciting for the team, those moments when you're finally really wanted. So that's a common workflow in a different way. I'm hoping the other panel members have had similar kinds of experiences.
You mean free work given to them for doing a good job?
Paying work, I hope.
Yeah, of course. But those blueprints do come out pretty fast, eh?
Yeah, if you've got a good drafter.
All right, so at this point, we'd like to open up the floor to any questions that people from the audience may have, if there is any at this point. I know it's always hard to pull the first question out of someone. It's always someone has to break the ice. But so anyone have a question that they'd like to ask? No one unmuted, but there is one in the chat box. So it's a question kind of geared towards the U of A, I guess, which would you tell us about tailings projects that the U of A has been working on? So I'm not sure who wants to jump on this one from the panelists. I know there's a couple of good options, but I'll let whoever unmutes themselves first go at it.
I mean, I can jump in. We have a lot of exciting work in terms of research at the U of A. Some of it is confidential. So if I tell you, I'm going to have to, no, I'm kidding. Some of it really involves the use of novel polymers that we have designed in-house at the U of A. Our colleagues actually at the chemical engineering department designed a couple of new polymers that we have been testing on how is the long-term effect on dewatering of oil sands tailings. But our projects aren't exclusively about oil sands tailings. We work a lot about just a few years ago, I guess now 2 years ago, really exciting project on the Diavik diamond mine, where we designed a coupled geophysical and geochemical model. We sort of try to understand how the tailings, as they consolidate, and what is the drainage effluent quality that is coming out of these tailings in a situation where you have the deposition is under complete water. And I hope I'm not saying a lot of jargon. I feel like I am. So please feel free to unmute and stop me. And we have, of course, the centrifuge to test also tailings consolidations, but there is a lot of cool work. And if I talk all about it, I'm going to take the entire panel, so I won't.
Well, I'd like to take a moment to highlight Haley Schaefer's work that might be of more general interest as well. She's working on about halfway through her PhD at the University of Alberta, and is looking at the long-term stability of tailings dams in the coal and oil sands industry, and looking at some technical aspects, but also looking at assessing long-term risks, and how do you figure out what's an acceptable risk, and how do you calculate the risks, and how should we be designing these landforms that can, tailings landforms that can, are expected to last 1,000 years or more. It builds on Nelsha's research from the last couple of years and work that I started years ago, but she's really made it her own. She's gone and interviewed, I don't know, 15 or 20 leading world experts in tailings dam design and construction and regulation, and not only learned a lot, but also introduced herself to the whole industry, anyone who didn't already know her. And she's also dealing with the tough side of risk acceptance. So just because we can plot it on an FN curve or on our risk assessment areas, the First Nations may have a much different view of what's acceptable risk. The regulator probably has a third view. The local communities living below the dam might have a fourth view. Not just the engineering, chemical engineering kind of risk acceptance matrix. And so her PhD research, like all good research, touches on very many areas, and is also going to open up quite a few areas in terms of geomorphology, in terms of risk, in terms of design, and in terms of working with local communities. So I encourage you to watch her advance there.
That's great. I think Ahlam pointed to something about a lot of people maybe not knowing exactly all the terms that she was using. So maybe Deji, could you explain exactly what tailings is, since our group is pretty heavily focused on tailings here. So maybe just giving like a brief overview of what tailings are, and maybe just kind of how we are currently handling them, or just a brief introduction if you could.
How many minutes do we have? 1 hour?
As many as you like. We have quite a bit of time left.
Well, I just maybe simply say it's in broad terms, it's a mixture of solids, fines, and some coarse particles with water and some residual bitumen in some cases. And it's for the most part, it starts out as a slurry, right? And tailings in general, I like to look at it's sort of it's it's a really interesting material. It's depending on what consistency you're looking at, it's neither a fluid nor a solid. It's something in between, right? So it's a material that you need to not only have a really good grasp of soil mechanics, for instance, to understand the consistency when it's below the liquid limit, for instance, but also you need to have a really good understanding of fluid mechanics when it's not quite a soil yet. So in short, it's a mixture of solids, water, some residual bitumen that, in general, the goal in tailings management is you want to convert that slurry material into a substrate that's competent enough for you to be able to incorporate into your final closure landscape.
Thank you. Would anyone like to add on that or no?
Maybe I add a little bit.
Sure, go ahead.
So I was, I guess like many of youngsters like to learn about tailing. So essentially it's a field that you get to play with, sand and also clay in all kind of basically a wide variety of like moisture content. So you can have a very soupy soil, you can have a very strong soil. You get to deal with this like in engineering matters, like how do you actually try to put a load on these different things, how to build a landform, things like that. But you have to be able to understand how they actually gonna actually react with different kind of action that you're gonna actually put on them. So it's very interesting because like you not only have a sandbox, you also have clay and other different things working all together in one soup. Yeah, so it's great, it's complex, and it's a lot of fun. Yeah.
That's great. Yeah, I think it's a very interesting material, a very difficult material to deal with for geotechnical engineers and geoenvironmental engineers. So it's a very specialized type of geotechnical or geoenvironmental engineering that all of our panelists are kind of involved in that are here today. So we do have another question from the group in the chat here, sorry, from Kyle Crewman. So I'm a first-year engineering student and I'm curious as to what discipline I should go into if I want a career in geosciences. Maybe Nelsha? I feel like we haven't heard from you in a while.
Yeah, so that's a tough question. I mean, nobody can tell you what discipline you should go into. I started out in earth sci and then kind of diverged and came back. But I think there are a number of things that you can do that will help to narrow that field. And just because you know, you might want a career in geoscience now, it might get more specialized as you practice. So the best thing I would recommend is just to get involved in as much as you can about it. So if you have an opportunity to do summer work terms or a co-op term, try out different areas. Sometimes it sounds a little bit weird at first, but then you grow to really like it, and that might end up being your career path or career path for a period of time. But it's hard to predict these things, so just get out there and do as much as you can, and kind of get involved and get exposed, and something will come of it. You know, you kind of, it's hard to plan these things entirely from the beginning, but if you know you like a certain area, then maybe start with a summer job and see if you like it, or if you're exposed to something else you might like to try the next summer. Another thing is, I think a lot of people in geoscience that I've spoken with, they kind of lack a basic awareness of career paths related to mine closure and also to consulting. So I would say don't rule out those two areas as well. I'm a little bit biased, obviously, but you know, you don't have to work for a strictly geoscience company or a mine or something like that. Consulting is a great option to get exposed to a whole bunch of different areas of application all at once. And similarly, mine closure is a fantastic and growing area that has a lot of geoscience integrated into it. So I would look at all these areas. Sorry, that probably opened up more questions than answers, but.
Yeah, so just to simplify it too from what Nelsha was saying, so there is a lot of different ways to get into this, including hers, which started from a completely different background. So it's not one traditional way, but definitely civil engineering, a path in civil engineering is the most straight line path for an engineering student into geosciences. It's a discipline that becomes geotechnical engineering in third year at the U of A. Does anyone else want to add to that particular question?
Maybe just Gord here, just to add, if geoscience in particular is your favorite, then you might want to switch over to the geology department. You'll want to be careful. I don't know about U of A, but some places offer earth sciences versus geology, and one you can get your PGL and the other you can't. So whatever program you're in, if you're looking for it for a career, you really need your PGL program. You have to give up some planetary science and stuff like that. But and if like Kevin mentioned, within the U of A geotechnical realm, yeah, it's the civil engineering program. You don't come out with an awful lot of geotechnical, but not a lot of geology actually. Some other universities offer geological engineering or engineering geology programs that may also be of interest, or you can pick up some additional geology things, as many of us have done in our master's program.
That's great, thank you. I'll first open it up. Does anyone actually want to unmute themselves and ask a question yet? Anyone feeling frisky? That's a no.
Kevin.
Oh yeah,
Kevin,
go
I'll ask you a quick question here. Kind of general and might be difficult to answer, but I'm curious as for the panel what their thoughts are on how to cultivate an environment of new design approaches and innovation in a non-academic setting. So I've had some opportunity to do this, but in consulting and in industry, there's always a lot resistance to this because it's usually costs more money. So what are your thoughts on that?
Yeah, maybe I can speak from my perspective. So I work in R&D for Syncrude, and by nature, well, Syncrude in general as a company is a innovation-driven, mining organization. But particularly, we've got R&D in our DNA, and so R&D department is a really critical, department for the company. My experience is, generally people are very open to, you bring in whatever, new design or new technology you're trying to investigate. People are very, very open to it. Of course, there are systems in terms of how you frame, and you got to have a logical sequence of events in terms of investigating your new design, and essentially qualifying that new design. So it's not a ticket to just run out and do whatever you want. Whatever your new idea has to have a business value, of course, but also has to be well thought out and well articulated to be able to move forward. So I don't think it's it's in my experience it's always a welcome welcome opportunity if you have something that's new and could potentially help to to move the needle in terms of innovation and solving practical environmental sustainability problems.
Maybe I could add a dangerous concept to that, and it's something called job crafting. And that's where you take your normal job and your normal job description, and you do a really good job of that. But you can actually, over the years, change what you work on and the kinds of projects that you work on and what you become an expert in. By picking up some little projects on the side or doing things, you can actually create the job around what you want to do and your skills, especially in a big company, and hopefully with the support of your boss. It's a good way to also get fired for not getting your day job done. So you got to do that. But an example for me, and again at Syncrude, working in the mine back when there were drag lines and that, one of the people there was experimenting a bit with grouted in piezometers. So putting in instruments in the ground that measure the pore water pressure like a farmer's well, but we found that we could actually skip the installation, a bunch of the methods in that, and just grout the whole thing up with a cement bentonite grout. So I worked kind of maybe half a day a week for a couple of years figuring this out, and we got a couple good papers out of it that saved the company several $1 million over time. And I think within the literature, I'm more known for grouted piezometers than my passion of landform design. And so as long as you have the support of people around you and you can take on practical projects that are likely to produce some good results and job craft your way into it. Maybe when you're selecting your employers, find a company that is open to that kind of innovation.
Yeah, thanks. That's a great example. And yeah, getting into a company that has an existing R&D component, spearheading that yourself, I think that's a great idea too. Thank you.
We have a question in the chat box, something that I'm unfamiliar with, but it asks, could you please explain a little bit on tailing tunnels? I'm not sure if anyone is familiar with what that is or not, or if Saeed, if you want to maybe unmute yourself and ask that question. Seems like a no. Okay, we'll just move on to the next one then. What are some ways that the advancements made in mine tailings management thanks to folks like you, have affected the design of new mines? How do these advancements affect the eventual remediation and reclamation of the newly designed mines? And then it was just a thank you. So I guess those are the two parts of the question. Anyone want to jump on?
I can start with a really simple example. So working in landform design, particularly with waste rock dumps, we tend to create these kind of layer cake-like structures. So it kind of looks like a wedding cake, and the sides aren't perfectly straight, but they're as close to angle of repose as you would get. And that's not very good for closure. So one thing that we have been seeing and helping design with more regularly is development of where those layers and where those kind of benches between the slopes go right from the beginning, so that when you go to push down that slope and create something more natural looking at the end of the mine life, or if you're lucky enough to be able to progressively reclaim your site, when that happens, it reduces the amount of earth movement quite a bit. So we can undulate those benches both horizontally, and then when you kind of mow them down, you end up with a little bit of a wave pattern and different slopes along that side that really help later on. And so, yeah, that's just a really simple example. I'm sure Gord has a number of other examples. I can think of end of pipe location and things like that, perhaps can pick up on.
Yeah, a different example along the same lines is filtered tailings or dry stack tailings that I do some consulting for a small mine, a very small underground mine, and they've got a single dry stack landform. Their annual production of tailings is about the same as about 1 minute for an oil sand mine. And so they have 3 or 4 truckloads a day that go out and deposit it, but they're able to do it completely by filling. They're able to make something that is controlling the acid rock drainage and very, very easy to reclaim. And we're quite keen on the dry stack generally, but it is in subalpine conditions, in very wet northern conditions, and it's hard to filter stuff to get it quite below or anywhere near really the Proctor value, optimum moisture you'd like, and so filtered tailings are a real bother in the field, and take some pretty good control to be able to get your compaction in that. But it's not a dam. It has, as long as it's compacted, there's no catastrophic breach potential, and it's extremely easy to reclaim. But it's quite expensive and quite an operational bother. So there's no silver lining, but it's those kinds of advances that are helping the mines out, depending upon their economics and their geography and the ore body and everything else.
And just to pick up on that as well, there's an ICOLD bulletin that goes through closure of tailings facilities, and some approaches that can be used that aid in closure. So that might be a good reference as well for you if you require something that's documented.
And if I may jump in also real quickly about the example about the waste rock dumps and the question, going back to the question about industry and academia and how they work together. I always like to think about the two as like the 2 strands of the DNA. And so our work always informs, and I'm going to go back to the example of waste rock dumps, because we know from our research at the side of academia that this is the end dumping waste rock from a truck is like the perfect design for creating ARD, bar none. And we realize that it's probably the easiest thing to do, having the trucks come in and dump all these rocks. But this is like it is like, it's creating reactive waste rock. And that maybe the solution that we propose from academia, saying that, well, you're going to have to do it and in stacking, and also Gord commented on this, it's not always easy to sort of implement these solutions, and then again you have the economic factors come in. So sometimes some of these solutions take time, but eventually the work of like these two sort of streams of the industry, like the practice and the theory in academia, they do really go hand in hand.
I saw Deji unmuted there too. Were you wanting to say something?
No, I just wanted to add that I think for newer minds, the recognition of the fact that tailings or tailings management is closely linked to the ability to, if successfully close the mine, is getting stronger. And now people design newer mines actually thinking about the end in mind, right? In terms of what kind of tailings technologies do they need to implement from close to day one to be able to ensure that you have progressive reclamation as you move forward.
Thanks. I'm gonna move away from tailings for a second with this question, and we'll see if any of you feel keen enough to answer it. But someone was interested in learning about how tunnels are advanced and how the geoscience profession kind of works around tunnels. I know that's not any of your expertise, but if someone wants to just pipe up a bit about kind of how we work with them.
Gord here, there used to be a U of A graduate level course in civil tunneling by Dan Eisenstein, and it's a whole field into itself. I think you can get your PhD in mine openings and tunnels and rock mechanics and that. So there's a bunch of old-fashioned methods with drill and pick and drill and blast and that, all the way to the big tunnel boring machines, and all sorts of different things employed in the civil side, and some of those are adopted in mining as well. So that's not a very long answer to your question, because that's not our expertise, but we could probably hook you up offline with someone who does it for a living.
Yeah, if you are interested, there's a prof at the U of A, Derek Martin, who is one of the leaders in rock mechanics and tunneling and things like that. He'd probably be one of the best contacts that we know of at the U of A. If you were so inclined, you could always message me or send us an email through our website, and we can hook you guys up. Just to go to another question, for a PhD or a master's program, how is the research chosen? Is it proposed by the supervisor, or as a student can I propose it? And we can go to Silawat for this. Since you're all PhDs, I'm sure you're well versed in this this topic.
I see. So this is I think like the process changed over the years, but during my time, like basically we walk to to see different professor, and basically like it's almost like around kind of like interview. So you would go from one office to another, and to see like if there are any like sparkling going on between the professor and student. But essentially like basically like professor would try to understand like if you're interested in particular research that he's working on, and whether like you're capable of doing some of the things that he like to do. And you know, if that turned out to be like, you know, a good you know, chemistry going on, then like, you know, you basically that's how I got like selected to do what I was doing. Yeah, maybe like Gord has other experience there.
Yeah, I went to talk to Professors Morgenstern and Seago, and I said, kind of interested in landslides. And they paused and they said, how about landform design? And set me on a new career path. So I think for every pair of professor and student, there's a different answer. Sometimes it's part of a big program. The University of Alberta does really well in that with their CanLex program, there's permafrost programs over the years and different things. Sometimes it's one-off. Sometimes the student comes with funding. Sometimes there's a specific pot of funds that are available to do something. So I'd encourage the person asking the question to kind of shop around. At the same time, oddly enough, maybe at a master's level too, maybe it doesn't really matter. You know, you're mainly at a master's level, you're mainly learning the technical side and the research. You may or may not be doing that for the rest of your career, but you're going to pick up such valuable skills along the way. And it's probably more important that you've got a good rapport with your professor than the actual topic. And I don't know what the other panelists think of that. It's a bit of hearsay, but a PhD, you probably want to get something that's a little closer to your passion.
Well, actually, like I want to add to that as well. Like I think this is great. Like, you know, to keep learning and learning the process of thinking. It's something that, like, you know, taught very well, like from the University of Alberta. So I think, like, you know, the process of learning essentially can go a long way and apply to different problems that you may face in the future.
Thank you both. So we're coming near to the time. I'll see if anyone wants to unmute themselves to ask a question. I see Sean just popped his head in, so maybe he's in for one.
Yeah, not so much a question. But it's nice to see friends among the audience. And for those who don't know me, my name is Sean Mckeon. I'm president of the Geotechnical Society of Edmonton for this year. And I wanted to compliment you, Kevin, and the entire UAlberta CGS Student Chapter on the enthusiasm and energy and success that you're having in so soon after being established. And I hope you continue to get this kind of support, you know, good large audience after working hours. So well done. And yeah, I'll let somebody else ask a question now.
Anyone else want to pipe up? If not, I have one more that was a private message. I think if no one else, we'll do this as our last question then. So I think with having a panelist full of PhDs, people get scared that you have to have a PhD to work in this field. So the question is, since each of you have PhDs, what made you decide to go back for graduate studies? Was it necessary to work in the industry? Maybe we can start with Ahlam.
I mean, I wouldn't say it's necessary per se. The reason I pursued a PhD is it was my passion to be able to work with students and teach students, and I wanted to get into academia, and that's why I pursued a PhD. But if you're looking into the industry aspect, having a master's is probably good enough, and I'm sure others on the panel, Deji or Gord, would be able to speak more to that. But I don't think it's necessary if you're going into an industry type in consulting.
I'll add by saying it's odd, but if you don't like or if you don't have the passion to do a PhD, don't do a PhD. To be honest, it could be frustrating to you if you don't have the passion for it, right? I say that, you know, your master's degree, you know, helps you to learn how to do research, and your PhD gives you the opportunity to actually do independent research, right? So if you want to do a PhD, do it because you really want to do it. Don't do it because of X, Y, and Z. And depending on the industry you work in, consulting industry, you know, academia, and so on and so forth, a PhD may be required, but you don't really, I don't think you need to have a PhD to be a good geotechnical engineer.
Yeah, I'd echo that, and it's an ongoing debate. You may not know, but the university engineering programs have external consultants and people that, or external representatives who evaluate the graduates that come out and provide feedback to the university and to the accreditation board as part of for your P-Eng and that. And they find in geotechnical, last I heard, that the undergraduate program did very well, that you can get your P-Eng, you can do work for your whole career with a bachelor's level education in engineering. And I don't know what the numbers are, but I think it was about 80% people stop at their bachelor's. With geotechnical, it's starting to, there's a lot more to know now, and there's a lot more things for expertise in. And so if you want to keep it for your whole career, I think personally that you'd like to have a master's. I'm not sure the MEng is still available. I really liked that program that has more courses and doesn't have a thesis. But there's also the thesis option with the MSc, and might be your only option at U of A these days. And that allows you to get really solid critical thinking skills, and you get 10 graduate level courses, or 8 to 10 graduate level courses, and really helps you in the geotechnical field. And then if one of those areas is especially interested, you, like Deji, follow your passion and go on. It took me 8 years part-time to do mine, so it's a huge investment. It's hard on marriages. They don't tell you that. I was thankful to have a very supportive wife and family. And so it's a big event, but it's also, you know, these days you can usually, between being a TA and scholarship kind of things, it's usually revenue neutral. So you need not come out with a debt for it. So there's lots of options. I think the world needs quite a few people with graduate degrees. Whether you want to go all the way to the PhD, I can attest it has opened so many doors for me for review board work or other research work, and no one can really ask you to do more after that. Some of my colleagues go back for MBAs on top of that. You know, there's no end to what you could do, but when I finish my final test, I don't even want to get a blood test. I'm done with testing and that, and I'm glad I did it. But it's like Deji sort of hinting at, it's a real haul. Immensely rewarding though.
Thank you, God. Like, I just want to add one more thing. It's like doing a postgraduate degree, like a master or PhD, actually also give us an opportunity to work with really high caliber engineers, and get to work with and learn from them is something that that we do it every day now as well. Like, it's essentially like a super good experience, I would say. Yeah.
Yeah, and just to add on that, I see a lot of geoscientists and geotechnical engineers that do quite well for 5, 6, 7 years consulting with just a bachelor's. But I tend to observe kind of a limitation in that you have to be really diligent to self-teach yourself some of the more complex areas of material behavior and whatnot. And some people just don't deal very well with that. So there tends to be around that time frame this kind of need to increase your knowledge to continue to move your career forward and take on bigger and more complex jobs. And at that point, I see a lot of people going back and getting master's degrees. I think it goes both ways. Having some work experience can really help you in your master's, but also having that additional graduate exposure to more complicated material properties and how to manage these things, and an understanding of how these materials actually behave is quite beneficial, even in consulting.
That's a great answer, and I'm glad that everyone kind of got a little time in there to pipe up and give us their point of view on it. I'm actually in the group of the last group that Nelsha talked about, who ended up working for about 5-6 years and then realizing that probably to keep going to push through in the industry, you need a little bit more base knowledge and technical knowledge. And I think that coming back to school and doing my master's and now PhD has really helped me learn kind of the more technical side of things that I was missing. And you don't think you're missing until you really come back and start looking at the nuances of it all. But we're gonna conclude there. So thank you all so much for joining us today. We'd like to thank our wonderful panelists for their insightful answers and for them spending their time with us. Thank you to all the individuals who made this event possible, with a special thanks to our leader for this event, who was Rima. And of course, thank you to all the participants for joining and engaging our panelists today. We hope that you enjoyed the event and will think about pursuing a career in geoscience. Don't forget to, if you're interested in getting involved with the UA CGS Student Chapter, send us a message through our website on our Contact Us page. So thank you, everyone, and good night. We can stop the recording there.
Thank you.
Thank you, Kevin and Rima. It's been a pleasure.